on in our venture with gas laws. Okay, our last video we did a Charles law introduction. Today we're going to do some simple calculations. Okay, no problem. All right, so Charles law. We agreed, right, that Charles law experiments, science did some experiments, and he did the experiments at constant pressure with the gases, right? So we have our original gas law, right? P1, V1 over T1 equals to P2, V2 over T2, right? Now what happens with Charles' law? Since pressure is constant, we could turn them into the unit one, just one number one, and basically we can get rid of them, we can cancel them out, all right? Now what we're left with, guys, is V1 over T1 equals to V2 over T2. Now we expressed before, right, that you gotta know what the V's, the P's, and the T's mean. You gotta know what the ones and the twos mean, right? We talked about before, but the ones mean initial condition, starting condition, all condition, and the twos mean the final condition, ending condition, or the new condition. Because if you don't know that, you'll mix and match and you'll get it wrong, okay? So make sure you know what the variables mean, volume, temperature, and pressure mean, and the ones and the twos, okay? No problem. So we jump into this problem right here. Now what we always like to do, guys, is to label our variables before we jump into any type of calculations, right? So we notice, right, calculate the temperature. So we are trying to find temperature, right? Okay, we continue reading, right? Now when 2 liters, now we know liters is volume. Now I've been noticing, right, some students having issues with understanding what the particular units mean for the particular variable. Like if you don't know what the units for temperature are, the units for masses, or units for pressure is, you gotta research it, folks. Research it and know it, because then you won't know what to put where. Okay, it's very important. So it's like being able to write an essay. In order to write an essay, you have to know the right paragraphs, right? In order to write paragraphs, you gotta write sentences. In order to write sentences, you gotta know words. And to write words, you gotta, know letters, okay? So you gotta know the basics before you can start doing any calculations. Just don't sit there, oh my gosh, I can't do these calculations. Go to the very bottom and go through each thing that you're supposed to know, and you'll get through it, okay? No problem. So, getting back to this. We got 2 liters, this is volume. We're starting with 2 liters, this is our initial volume, so that will be our V1, okay? So you make a note someplace, either on the side, okay, or a little above the actual numbers, the actual variables, no problem. Now it says, right, if you guys can see, it's at 20 degrees C, right? Now we established before, guys, that we always use what? We use Kelvin temperature. All right, Kelvin temperature, short. All right, very important. Now, guys, if you don't know how to convert degrees C to Kelvin, no problem. What you do, you got your reference table. All right, you look in the back, and at the very bottom of table T, okay, you'll see there's a temperature conversion there for you, formula. It makes life very, very simple, right? And to convert degrees C to Kelvin, whatever degree C you have, you simply add 273 to it, all right? No problem. So, our starting temperature, right, is 20 degrees C. We're not gonna use it as degree C, we're gonna use it as Kelvin. So we're gonna add 273 to that. So our initial temperature, our starting temperature, is gonna be 293 Kelvin, okay? So we have our V1 and we have our T1, okay? And we continue reading. It's compressed to 0.5 liters. So this is our new volume, okay? This is our ending volume, all right? So this right here is gonna be our V2, all right? So we know V1 and V2, we know T1, we want to know T2. So we have our formula, guys, up here. Now we established before, right, that we're not gonna use it just like this. I like to crisscross the temperatures first before I use it. Okay, so it's gonna be, right, when we crisscross, this T2 over here, and this T1 over there, right? We're gonna get V1 times T2, okay, equals to V2 times T1. Okay, T1 goes up there. Now here we have it like this, right? No problem. So what are we looking for? We are looking for T2. T2 is our X, T2 is our question mark. So what do we want to do? We want to isolate T2, guys, okay? So we want to isolate this guy right here. So you can put an imaginary box around it, alrighty? Now, how do we isolate variables? Simply, whatever's next to the variable, okay, whatever variables are next to it, it could be one thing, two things, or whatever, you will divide both sides of the equation by that variable, okay, whatever's next to it. So it just so happens V1 is next to the T1 that we're looking for, that we want to isolate. So we're going to divide both sides, okay, by V1. So we're going to slowly here, carefully, divide both sides by V1. Now you might say, I can do this in my head, I can blah, 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 but when you take the little extra 1 or 2 minutes, it guarantees you almost 100% chance of getting the answer correctly. Or if you make a mistake, you can see what units you messed up with. But if you try to do it in your head or do it really quickly, okay, you're more prone to make mistakes, okay? No problem. All right, so what happens? This V1 and this V1, they can now cancel, so we can erase them, right? Or we can cross them out, okay? Now our T2 is going to be equal to V2, T1 over V1. Now what we have to do carefully, guys, we have to put our numbers in carefully for our variables. That's the only thing right now that can mess you up, okay? So our V2, you guys with me? V2 is 0.5 liters. You can put that there. I'll put it here very small, 0.5 liters. Alrighty? Okay. Our T1 is 293. So I'm going to put it up there. Now you could put it over here and work it out over here, folks. But I'm just putting it over in the variables, you know, so you can see we're nicely matched. Okay? And our V1 is 2 liters, right? So 2 liters goes there. Notice I'm using units, right? Bam. Okay? Why am I using units? Because I see that I have liters in the top and liters in the bottom. They cancel out. They leave me with Kelvin. I'm looking for temperature. I know I'm on the right track. Now let's say the units didn't cancel properly, or they give me a different unit. I know I made a mistake. I know I have to fix something. I made a mistake with plugging in or whatever, okay? So use units, guys. Okay, so winding down on this problem. We have 0.5 here, and we have 293 there. So, you have our calculators? Okay. All right, then, clear. All right, so 0.5. Okay, times 293 equals to that. 10 divide that. Okay. All right. Times 293 equals divided by 2.0 equals. Okay. Let's see, one more time. Got 73.25. I'll do it one more time to make sure I'm correct. I didn't plug anything incorrectly. 0.5 times 293. There was a time I could do this in my head really quick. The age is betraying me. Okay. All right. So 146.5. That makes sense. Divided by 2. Okay. 73.25. Okay, is the answer, and the answer would be Kelvin. Okay, you can have 73. You can round it to 1 decimal place. 73.3 Kelvin. Either or is fine. Now, guys, you got to be careful. If the problem asks you to do it in sig fig rules, follow sig fig rules, right? But I normally tell my students 1 decimal place is fine for the final answer. No problem. All right, guys. So that was a simple Charles law problem. Okay. Now you ask yourself before you leave, right? Does your answer make sense? Okay. We know temperature and volume have a direct and proportional relationship. So whatever temperature does, volume does also. Think of a hot air balloon, right? Okay. So what are we doing? We are going from 2 liters, okay, to 0.5 liters. So since the relationship is direct and proportional, the volume is decreasing, okay? Therefore, we expect the temperature to decrease also. Think of it like you have a hot air balloon and you're putting in a cold environment, okay? The particles get closer together, okay? The volume will shrink, so our answer makes sense. Got lower. Okay. Let's do one more. Call it a day. what is the volume at 80 degrees C? Okay? So as always, what do? We label our variables. Okay, so 800 mils is going to be what? It's going to be V1, okay, our starting volume. It's at 25 degrees, okay, so we know that's our temperature one, starting temperature, right? Now, do we use degrees C, guys? No, we don't. We add what? We add 273 to change degrees C to Kelvin, right? So we're going to add 273 to 25, and that just so happens to be what? 298 Kelvin, okay? So we know our V1, we know our T1, okay? Now, over here, they're saying at 80 degrees, so this is our T2, right? Okay, but remember, we're not gonna use degree C, right? So 273 plus 100 is 373, minus 20, that's 353 if I'm not mistaken. Okay, so 353 Kelvin is going to be our T2, all right? Now, guys, if you can't do it in your head in terms of addition or whatever, no shame, use your calculator, no problem, all right? So, what do we have? We once again have, guys, V1 over T1 equals to V2 over T2. This is Charles' law, okay? Pressure's constant. Now, remember, they can tell you it's constant pressure, or can they just not mention it? If they do not mention it, assume pressure's constant, right? And we're dealing with a Charles' law problem. So we're gonna crisscross our temperatures, okay, to make our life simple. So we're gonna get V1 again, T2, all right? We're crisscrossing the temperatures, all righty? Equals to what? Equals to V2, T1. This T1 goes over there, V2, T1. Okay, now what are we trying to do now? We are looking for volume. We have our initial volume right there. So we are looking for V2. V2 is our X, V2 is our question mark. We're looking for volume 2 this time, final volume. So we put our imaginary box around this guy, okay? We want to isolate V2. Now, how do you isolate? Okay, you divide both sides by whatever variable is next to the guy that you're looking for. So we're looking at V2, what's next to it, T1. So both sides get divided by T1. Okay, we're going slowly and carefully here. We're seeing how we solve this guy. We're not guessing, we're not mixing and matching. The T1s will cancel out, okay, on this side. Now we have V1, T2 over T1. We're going to plug our variables in carefully, and we're good to go. All right, so V1 is 800 mLs. We got a nice little label over there, 800 mLs, right? Put that there, bam, okay? Our T2, you gotta be careful, T2 is 353, all right? Don't mix and match the temperatures, because the only thing that can mess you up, okay? If you put the T1 and T2 in the wrong place in this problem, right? No problem. So we have guys labeled, we look at it carefully, and we choose them, right? And our T1 is 298. 298 Kelvin, okay? You look at it carefully. We got Kelvin here, we got Kelvin there. They cancel. We're left with mLs. We're looking for volume. We're on the right track. We're kind of happy. All right, so calculator. You have 800, all right, times 353. All right, that's equal to that. We're going to divide that by 298. Okay, and it equals to 947.7 approximately. Okay, let me do it one more time. Clear. We got 800 times 353. Bam. Equals to that. Divided by 298. Bam. Oh goodness. Okay, one more time. 800. So I like to do it a couple of times to make sure I'm on the right track, folks. Times 353 equals that. Divided by 298. 298 equals to 947.7. Okay, so there we go. Bam. So 947. Okay, 0.7 mLs. Alrighty. So that's our new volume. That's our V2. Okay, and you're done. Before we leave, you ask yourself, does the answer make sense? Okay? What's the rule? It's Charles' law. direct and proportional relationship. As temperature goes up, volume goes up. If temperature goes down, volume goes down, right? What did we do? We went from 25 degrees to 80 degrees. We expect our volume to do what? To go up. Did our volume go up? It went from 800 to 947. It did. We're happy. All right. As always, guys, hard work with sacrifice equals success. Know your units, know your variables, okay? Review, okay? And these problems are very simple. Set them up properly. You're good to go. All right. Take care.